Hello students, welcome to Study Bay Technologies. In our today's session, we will discuss a few details related to tangent of circle. So let me start from here, and we have a circle over here, and you can see like we have a red line which I have drawn over this circle. This is intersecting this particular circle at two different points. And these type of lines are actually called as secant. Now if I move this line and put it somewhere so that it can just touch the circle at some specific point or at only one particular point, then this type of line will be called as tangent. So now remember one very important property of a tangent, that a tangent is a straight line which just touches the circle at one and only one point. Okay, so we have a lot of applications related to the tangent line. You can see it in the field of sports. While throwing a discus, it will move towards the line of tangent, so the circle which is created by the player. In the similar way, while throwing a sling, you can see like this stone will move in the line which is tangent towards the circle which is created by the sling. And a very important application of the same is under the astronomy. You might have heard about the partial moon lunar eclipse or full lunar eclipse, or the area which is covered by the full lunar eclipse and area covered by the partial lunar eclipse, and so on. You can directly see here that the sunlight are going ahead in such a way that they are tangent to the moon, and based on that we can find out the area over which we will have full lunar eclipse and the area where we have partial lunar eclipse. Right? You can see that all these lines are falling as a tangent towards the moon. Right? Now, let's say if I draw a line from the center of the circle which just touch the point where the tangent meets the circle, or the point of contact of tangent and circle. This is the radius here, and always remember that the radius drawn in the circle from center of the circle to the point of contact of tangent and circle will always be perpendicular to the tangent line. Okay, this particular radius will always be perpendicular to the tangent line. So now this at any point of a circle is perpendicular to the radius to the point of contact, and this is your theorem number 1. Similarly, let's say if I draw one more tangent line from the same point where the first tangent has been drawn, and again if I connect this tangent line or point of contact of the tangent and circle to the center through the radius, then we will find out that the length of these two tangents will be equal from the point of origination. Then this is your second theorem. The lengths of tangents drawn from an external point to a circle are always equal. The point of distance between the point of origination and the point of contact of the first tangent. Similarly, the distance between the point of origination and point of contact with circle for second tangent will always be equal. So once you attend our class, we will show you how to prove these two theorems and how we can use these theorems in our problems. Till then, have a nice time and take a very good care of yourself. Bye bye.